So we've talked about what to do when we're evaluating inverse trig functions where the values are on your unit circle. Now we want to know, what do we do if we don't recognize it from our unit circle? If we are certain that it is not on our unit circle, then we have to use a calculator. The very first thing you have to remember is to check your mode every single time. So for this first problem, we want to find y in radians if y is equal to the inverse cosecant of -3. Can cosecant even be -3? Remember, sine and cosine have to be between -1 and 1, and cosecant and secant have to be outside of that. They just can't be between. So -3 is outside of that, so we should get an answer for this. But what you have to remember is you cannot type cosecant into your calculator. You don't type the 1 over first. You'll have to use the inverse key first. So we type the second sine, and that's how we get inverse cosecant. Uh-oh. That's the same as that, right? And over here, because we're using sine instead of doing -3, we do -1 over 3. And it should give you a decimal because we're in radians. So give it to me. Let's do 4 decimal places. -0.3398. Did you guys round it properly? Yes. Okay. All right, that's perfect. Now let's see if that makes sense. Because it's a negative, it has to come from either quadrant 2 or 4. Sine and cosecant come out of quadrant 4. So those should have produced a negative answer, and it did. Does that make sense? Yes? Okay. It's really pretty straightforward to do these in your calculator, except if you're in the right mode. Where you get into trouble is cotangent. Your calculator can handle every inverse trig function, but it cannot handle cotangent. It will mess cotangent up every single time. So we need to pay really close attention to this one right here. If we want to find theta in degrees, so the first thing we need to do is go switch our mode to degrees. And we want to find the arc cotangent of -0.3541. Cotangent, when it's negative, pairs up with cosine and secant, and they have to come out of quadrant 2. So I need a quadrant 2 answer here. Does that make sense? Yes? Okay. How am I going to type it in my calculator? How do you tell the calculator, give me the angle for this cotangent? Second tangent, and because we changed it from cotangent to tangent, we have to flip this guy. 1 over -0.3541. Type that into your calculator and tell me what it gives you, and round it to the nearest tenth. -70.5 what?
0.
Oh no, I mean what are your units? Degrees, yeah. We'll round it to -70.5. Here's the problem with that. What quadrant is that from?
That's quadrant 4.
-70.5?
That's quadrant 4.
That's quadrant 4. Why does my calculator think that I want it from quadrant 4? Because what did I type in? I didn't type in inverse cotangent. I typed in inverse tangent. And because tangent comes from one quadrant and cotangent from another, your calculator can't distinguish the difference. It thinks you're asking for an inverse tangent. Now we know we're asking for an inverse cotangent, but there's no way to tell your calculator that. So the calculator is going to give you the answer from quadrant 4. And you have to know that because we really wanted cotangent, we have to relocate that into quadrant 2. And the way you fix it is you add 180, or if you're in radians, you add pi. And that will have to be done for every single inverse cotangent problem that you use your calculator for. So we will add 180, and that will relocate it out of quadrant 4. It'll move it halfway around and into quadrant 2. And if it's in radians, you would just add 1 pi. That gives me 109.5. So 109.5 degrees. And that is from quadrant 2. Now, if you were looking for tangent, the answer would be -70.5. But we were looking for the inverse cotangent. So this one is in quadrant 2. And so that's the tricky one. That's the one that people miss. Most people do really well with the calculator problems until they hit a cotangent problem. The other 5, your calculator will give you dead on the money. But cotangent, it will give you quadrant 4 every time, and you have to relocate it into quadrant 2. In case you didn't understand what I just told you about inverse cotangent in your calculator, we have a guest speaker here to tell you again.
Caution. Be careful when using a calculator to evaluate the inverse cotangent of a negative quantity. Enter the inverse tangent of the reciprocal of the negative quantity, which returns an angle in quadrant 4. Since inverse cotangent is negative in quadrant 2, adjust your calculator result by adding 180 degrees or pi accordingly.
Thank you, guest speaker. Did that clarify? Definitely. For our last couple of examples, we're not going to be using a calculator or the unit circle. You will recognize these examples because it will say evaluate each expression without a calculator, and it still won't be on your unit circle. Also, you'll notice that it will have a double trig function on it. So what this is asking us to find is the sine of the inverse tangent of 3/2. And we have to figure out a way to do that without a calculator, and especially because it's not in our unit circle, okay? First off, remember that when we work like a composite function, we work from the inside out, right? Okay, so let's look at the inside of that parenthesis. The inside of that is asking me to find the angle whose tangent is positive 3/2. So the inside is asking me for an angle. An angle from what quadrant? How do we know it's quadrant 1? Because it's positive, yeah. So forget about the sign for a minute and just think about it. If I had a triangle whose tangent was 3/2 and it was in quadrant 1. So come off to the side and draw a triangle in quadrant 1. This is the angle we're interested in right here. And if the tangent is positive 3/2, that's opposite over adjacent, or y over x. Make sense? I still don't know that angle. But that would be 1/2. No. Would no. No, that would be square root of 3 if it were 60. Yeah. It's not on your unit circle, right? We don't know anybody whose tangent is 3/2. We know the tangents for 1, 0, undefined. What else do we know? Square root of 3, square root of 3/3. None of those, that's not any of those. So we're going to have to use a triangle to figure this out. So you take the inside, you figure out which quadrant you're interested in, and you come over and draw a triangle. And then you use the Pythagorean theorem to complete that triangle. So x squared plus y squared equals r squared. So it looks like r squared is 13, and r, which is always positive, is the square root of 13. So now, even though I don't know that angle, I have a complete triangle for which that angle right here has a tangent value of 3/2. So this triangle right here makes the inside of this true. And because ultimately I'm not asking you to actually find that angle, I'm asking you in the end to find the sine value of that angle. So all you have to do is find the sine value of that triangle that you've drawn over there. That's what the answer to the problem is. So you actually never need an angle. You just need the sine of the angle that has that tangent value. And this triangle will make that true. So what is the sine value of that triangle?
3 square root of 13.
Oh, wait. Okay. It's opposite over hypotenuse, or y over r. So, okay, 3 over the square root of 13. And then you rationalize it to 3 square roots of 13 over 13. Does that make sense?
Yes.
Okay. So one more time, you work on the inside, you go draw into the proper quadrant, you draw the triangle, you complete the triangle, and then instead of actually finding the angle, because you're not supposed to use a calculator, you just go outside and say, all right, I really just want the sine of that angle in that triangle. And so it's really not a bad process at all if you know how to attack it. Here's the neat thing. You can check it in your calculator as long as you're in, it actually doesn't matter what mode because we're skipping over the angle. So go to your calculator and literally type this right here. Sine of second tangent of 3 over 2. And hit enter and tell me what it gives you. 0.83
205.
21-ish, something like that? Yeah? Okay. Type 3 squared root of 13 over 13 and make sure that it equals this. That's how you know you got it right. But guess how many points I'm going to give you if you only write 0.8321 in blank?
None.
None at all, because you have failed to do any of the trig that I asked you to do. But at least you can check your answers. Any questions about that one? Well, for the last one, I'm going to give you a chance to kind of try it on your own. I would like you to evaluate the tangent of the inverse cosine of negative 5 over 13. So we want the tangent of the inverse cosine of negative 5/13. I'm going to caution you that because we are dealing with the inverse cosine of a negative, this triangle does not belong in quadrant 1. You have to figure out where to draw this triangle. Okay, so what'd you guys get?
Negative 12.
Did everybody get negative 12/5? Okay, what quadrant did you draw your triangle in?
2.
2. Yeah, we can't use 4 because cosine would be positive in 4. So we have to draw it in quadrant 2. And we know that the cosine is adjacent over hypotenuse. And if we complete this triangle using the Pythagorean theorem, do you guys get that this is positive 12? Yes? Okay, so whatever this angle is, we don't really know. Whatever this angle is right here, we know that it has a cosine of negative 5/13. And now we can find that the tangent of that angle, which is the same as that triangle right there, that tangent is y over x, or 12 over negative 5. And we don't usually leave the negative in the denominator. We either float it to the middle or put it on top. So negative 12/5. And you could check it by using your calculator to make sure that you would actually get that. And that wraps up the final section of Unit 4. Okay? Your homework is due the next time I see you. So you need to be working diligently on that.